Well, thanks to coming to the Tampa MTTS. I'm going to take the next few minutes to talk about Microsemi's gallium nitride power transistors, especially designed for SWPE. A lot of people ask what that means. Most people know SWAP, SWMP, size, weight, and power. And add one more, E as efficiency. So efficiency is also important, as nowadays most of our customers are building these large systems for avionics and radar markets. They need multi-thousand watts, sometimes even higher, and they need to incorporate many of these power transistors. So as the device become more efficient, the overall system size can be smaller, and also the power consumption can be much better. LDMOS has been doing great in the past 3-4 years, but as GaN comes along, we see that GaN has many great advantages over the traditional silicon bipolar transistors and LDMOS. They primarily have a much higher power density that we can achieve much higher power level per devices, and also great temperature stability at extreme temperature like minus 55 to plus 85 degrees C. That alone, the junction temperature can handle 250 degrees C for GaN transistors versus most bipolar. 200 degrees C is the absolute maximum temperature the device can operate at. And also the efficiency factor comes into play, that you will see later on later slides that the GaN transistor has much superior efficiency performance over both the silicon BJT and the LDMOS. Okay, so today we're going to talk about 4 feature products. We actually have a GaN selection guide here that covers all 44 GaN products we have here, but let me pick 4 feature products that focus on GaN power. Power level from 400 watts to 600 watts to 800 watts up to 1,000 watts for different frequency band, SL band, for both avionics application and radar. So first, let's talk about the S band, 2.7 to 3.1 gigahertz for S band air traffic control radar. So in this one, we see at about 18 watts input, we can get over 400 watts across the band power transistors, and 14 dB again, very high gain compared to bipolar used to be about 7 and 8 dB, and efficiency above 50% across the full band. So if a customer wants to get to 1,000 watts amplifier, then they can just need to combine 4 of them. So one driving 4 is a typical, very traditional configuration most customers use. So we use this topology to introduce our product and design with size, power, weight, and efficiency in mind to make sure the customers can accomplish their system with these great benefits. All right, try to understand how sensitive this screen is. So besides the 400 watts power level we also have 100 watts and 200 watts for the intermediate stage to drive that. Now additionally, we also work on the long pulse application. Many customers says, well, your standard pulse format is great, but can it handle much longer, like millisecond or 25-30% duty cycle? So we also release a series of the power line called LV, long pulse 50 volt lineup, up to 300 watts at this point for the long pulse application. All right, let's talk about the L band, 600 watts. So this is for the 1.2 to 1.4 gigahertz, the L band radar. You can see a 10 watts input drive with 600 watts across the band. It's very high gain, 17 dB. Compared to bipolar, it's much higher. And most importantly is the efficiency. This one can achieve 60% across the band. At some frequency point, even 70%. Very high efficiency. And in a very small package. This package size is about 1 inch by 0.4. But if you really want to go even smaller size, if you trim off the ear, this can be only half inch by 0.4 inch. Extremely small size for this high performance transistor device. Now if we do a comparison versus different technology, bipolar, Microsemi also have the highest bipolar L-band transistor on the market, which is 370 watts. We sell in thousands of these devices in the past 3-4 years. Bias at 50 volt with 8 dB of GaN, which is state of the art at the time, in a hermetic package in this package size. Now LDMOS come along and say, hey, we can offer a 400 watt device also biased at 50 volt, but with much higher gain, 15 dB, and 45% efficiency. But they put it in a non-hermetic package in this epoxy seal lid with 1.6 by 0.4 size of the package. They also use like a Gemini package. Actually, they have about 250 watts per side, and then combine into a 400 watts. So when we developed GaN, last year we introduced 400 watts. This year we moved to the next step. We go up to 600 watts power level, also biased at a 50 volt with 17 dB of gain, which we offer about 2 dB higher gain than LDMOS, and then almost 9 dB higher than bipolar. The key here is efficiency, 60% efficiency across the band, compared to bipolar, which is Microsemi bipolar has a higher efficiency in the market. It's still higher than that by 5%, and also better than LDMOS. We also offer in a hermetic package similar to the bipolar, so can be used in the extreme temperature, very rough, tough environment conditions. Very small size, 1 inch by 0.4. So it's a good comparison between the different technologies. On these devices, similarly, we have driver stage for 20 watts all the way to 600 watts. If it is shorter poles, we also have a 650 watts. In a similar configuration, one driving 4, one device driver can drive 4 and easy to achieve over 2,000 watts of overall power level. Move to the next 800 watts. We have a product designed for avionics, which covers from 1025 to 1150 megahertz for the DME, distance measured equipment application for avionics. This one, single device, and the pulse can operate at peak power over 800 watts. You can see almost close to 1,000 watts with extremely high gain, 19 dB across the band. And because the bandwidth is a little bit narrower than previous 2731 and 1214, then you will see the efficiency can even more optimized to above 70%. So again, size, weight, power, and efficiency. These are the devices that we have very special technique to achieve this high performance measurement. So pretty clear to us and customer that size matters, power matters, but also efficiency also matters. Now we also work on the next level. How about 1,000 watts? Can we achieve 1,000 watts using GaN? So last year we talked about 700 watts devices for this frequency band, 1030 to 90, and we demonstrated this particular chart that has extreme stable temperature performance over extreme minus 55 to plus 85 degrees C. Some of the device in other technology at a minus 45 to minus 60 level, it drops pretty significantly. But the GaN technology has very stable temperature performance over very extreme range. Oops. So on that note, we move to the next level. 700 watts last year. This year we introduced 1,000 watts. A single transistor, not a Gemini package, not a push-pull combined. A single-ended at 1030 to 1090 megahertz. We can achieve 1,000 watts at 50 volt bias, right? At 50 volt, this is the first 50 volt bias can achieve such a high gain with 19 dB of gain, extremely high gain, and also efficiency 75 to 77%. This bias across the AB 20 nanosecond rise time. So you can see the dynamic range is pretty wide, very wide dynamic range. Normally it has 15 to 20 dB dynamic range, extremely wide because across the AB, and then you see the power curve come up very smoothly and at about 1100 watts level. So power matters, efficiency matters, and size matters. Smaller the size, higher the power, and best efficiency. Again, customers using 700 watts before, they have to use one driving A to achieve about 4,000 watts power level in the system. But with the new 1,000 watts, they can just one driving 4, back to the original configuration, one driving 4, which is significantly reduce their size, improve the efficiency and performance over 4,000 watts. So summary. So GaN technology has many advantages with highest power, best efficiency, and then we are able to design the product in such a small package in a hermetic format. And we have a leading product that across the L band, S band, from 600 watts, 400 watts, 800 watts, up to 1,000 watts for avionics, 1030, 1090 megahertz. We have a full portfolio. Anybody interested? There's a 44 models of GaN products cover all these frequency band, these applications listed here, and the typical configuration, one driving 4, how much power you can achieve using these transistors. If any information, you need more information about these products, you can contact Arrow, you can contact Microsemi. We generate a very unique email address, very easy to remember, gan@microsemi.com. Send that request in, we can respond to you. Okay, questions? All right, thank you.